In this video, we'll be considering the following grammar and check if it is LL1 or not. Also, we'll be showing the sequence of moves made by the parser on the given string W. And these are the string. The string comprises of open bracket and then the exponential symbol and close bracket. So here I've written down the steps. So the first step is to consider any string. So the string is given here. So we need to obtain its LMD along with its parse tree. So before moving on to the first step, we need to check if, let's consider this as grammar G. So our first step would be to check if grammar G is left recursive or left factored. If yes, in that case we need to eliminate them. So if you look at the first equation, there's neither left recursion nor left factoring here. But in the second equation, you can see that it is of the form A derives A, this entire thing let's take as alpha 1 and this as beta 1. So in that case we can write E derives alpha 1, E derives beta 1, that is S A dash, that is E dash. This would be, we obtained this from the second equation, and along with that we would get E dash derives comma S, that is alpha comma S E dash. So A is E here, E dash would be E dash here, and then alpha 1 is comma S and beta 1 is S. Followed by that we would have epsilon, that is in the third equation. So here we have obtained grammar which is free of left recursion. If you check, there is no left factoring required here. No elimination of left factoring is not required here. So let's consider this grammar as GLR. So we'll be computing all the further steps provided here by using this GLR grammar. So moving on to the second step, that was to consider now we'll start with the first step, that is to obtain LMD and its parse tree. So obtaining LMD and its parse tree for given string, that is W is equal to open bracket, exponential symbol and close bracket. So let me start. So here S derives LMD, S derives open bracket E and close bracket. Open bracket was required, yes. We'll change E symbol to this. So S derives E can be written as SE dash. So SE dash and close bracket. Now I'll change S value, that is from S I can write this exponential symbol, and E dash I'll keep it as it is. Now S derives, E dash derives epsilon. So epsilon you need not write here, so you will get only these three symbols which are present in the string. So now that you have obtained the LMD, now let's construct the parse tree. So starting from the start symbol, you have written open bracket E and close bracket. SE is split as S and E dash, and S is written as exponential symbol and E dash as epsilon. So yield of the tree, that is open bracket dollar symbol and close bracket, you would get W is equal to open bracket exponential symbol and close bracket. So you are done with the second step. So you are done with the first step actually in this. Moving on to the next step, that is computing first and follow. So let's start with first. So let me write down all the productions here. S derives A, S derives exponential, S derives parenthesized E, E derives SE dash, and E derives comma SE dash and E derives epsilon. So I'll quickly write first of all these productions. So if you remember the rules, so the rule 1 says that if A derives x, x being a terminal, then first of A would be equal to the same terminal. Rule 2 states that if A derives x1, x2, where x1 is a non-terminal, then first of A would be equal to non-epsilon first of x1. And rule 3 states that if A derives epsilon, then first of A would be equal to epsilon itself. So writing here, A is a non-terminal, so we'll apply the first rule, that is first of S you would get A, and here first of exponential symbol you'll get exponential symbol, and then here first of open bracket E and close bracket, you get here open bracket being the non-terminal, you get the same. Coming to this production, E derives SE dash, so here S is a non-terminal, so you write first of E is equal to non-epsilon S of non-epsilon first of S. So S has A exponential symbol and open bracket, so it will be the same, A exponential symbol in open bracket. Here next first of, here we have comma, so first of E is comma itself, that is using the first rule, and E derives epsilon, first of E is again, sorry, here it's E dash, first of E dash is epsilon. Now that we have computed first of the productions, let's write the follow also. So here I'll be writing the follow. So follow. So let me write down all the productions one by one. So S derives A, for this, so here I have written down the rules for follow. So let me start. So S derives A, S being the start symbol, we can write follow of S, we get dollar. Then for S derives exponential symbol, there has to be at least one non-terminal, so here there's no non-terminal, so you can't write anything. And here we have S derives open bracket E and close bracket. Comparing this with A derives alpha B beta, you can equal to non-epsilon first of beta of a non-epsilon first of close bracket. Non-epsilon first of any non-terminal is the same. So we are done with the first production. Let's take the second production, that is E derives SE dash. So comparing this with A derives alpha B beta, applying the second rule, we can write follow of S is equal to non-epsilon first of E dash, that is beta. So first of E dash we have comma and epsilon, so except the epsilon you get comma. So next, comparing this with the A derives alpha B, apply the third rule now. So follow of B can be taken as S here, so you get follow of E, that is A value. So follow of E is unknown. Follow of E from here is, we know that's open bracket, and on this side we can write follow of E dash, that is B, is equal to follow of E. Follow of E, we know that it is open bracket, so E dash, it's the same, open bracket only. So now moving on to the last production, that is E dash derives comma SE dash. So we can write, so there's a comma here, in that case we write follow of S, comparing this with A derives alpha B beta, follow of S is equal to non-epsilon E dash non-epsilon first of e dash. E dash we have comma and epsilon. Except the epsilon, what is that? Comma is left. So write comma here. Then comparing this with the second equation, you get follow of s. Sorry, third equation follow of s. Third equation follow of s derives follow of e dash. Follow of e dash we have open bracket. So for s also it will be the same open bracket only. Comparing this with the equation 3b, that is alpha b, so you get follow of e dash, which is equal to follow of e dash only. So now that we have computed the values of first and follow, let's draw a table, a consolidated table, and fill the values. So here I'll fill the table. First of s we have all the three symbols. For e also it's the same. And for e dash we have comma and epsilon. Follow of s, first we have dollar, comma, and follow of s is close bracket. And follow of e dash we have close bracket, and follow of e also we have close bracket. So we have computed the table of first and follow. Our next step is to obtain the predictive parsing table. So here I have drawn a table. So let's start writing the productions. We'll write the first of alpha values and then the final equation. So here there are the steps. So step 1, step 2 and step 3. So let's start with the first production, that is s derives a. So we'll write s derives a and compare it with a derives alpha. So we have to write first of alpha, first of a being the non-terminal, it would be the same. So we get a itself. So in that case we can write m of s. S here is m of a here is s, and small a here is small a itself. We get s derives a. Moving on to the next production, that is s derives exponential symbol. So first of exponential symbol is the same. So here m of s comma exponential symbol would give s derives exponential symbol. Similarly, s derives id I have here. So I'll compare this with s derives alpha. Taking this entire thing as alpha, I'll write first of bracket open id and close bracket. So I'll be considering the open bracket here. First of open bracket is open bracket itself. So m of s comma open bracket would give s derives parenthesized e. I'll take the entire thing here. It's id, so e here. Sorry, s derives e. Yes. Next, I'm done with the first production. Moving on to the second production, e derives se dash. Comparing this with a derives alpha, I can write first of se dash. First of se dash. So I'll consider first of s. First of s would give a exponential symbol and open bracket. So here I can write m of e comma a exponential symbol and open bracket would give e derives s e dash. So I am done with the second production. Moving on to the third production, that is e dash derives comma se dash. So here first of comma I would get first of comma se dash. So I'll be considering first of a comma, that is comma itself. So I can write m of e derives alpha. M of e dash comma would give e dash derives comma se dash. Moving on to the last production, that is e dash derives epsilon. If e dash is deriving epsilon, then we need to consider follow of a. So follow of a. So here PPT. So let's construct a table now. Now let me start filling the values here. That is s on a. S on E gives S derives C. So let me fill it here. So S on exponential operator gives S derives exponential operator, and S on open parenthesis E gives S derives parenthesized E. So next, coming to E, E on A gives E derives SE dash, then E on exponential also gives E derives SE dash, and E on open bracket also gives E on SE dash. So E dash on comma gives E dash derives SE dash, and E dash on close bracket gives E dash derives epsilon. So here I have completed the actual predictive parsing table. My next step is to show my next step is to check if it is LL1, if the given grammar is LL1 or not. So for that I need to look into this table. So multiple entries here. So we can say that the given grammar is LL1. So now that we have proved the given grammar is LL1, our next step would be to show the sequence of moves made by the parser for the given string by taking use of a stack. So let me construct a table for that. So here I have constructed the table. Let's start filling the values. So first dollar, and the start symbol here is S, right? So let's write S here. Here in the input we have to write the given string followed by a dollar. So the string here is open bracket exponential symbol and close bracket followed by a dollar. Now we need to start the checking if the combinations exist in the parsing table or not. So first I'll take S and open bracket. So M of S comma open bracket is equal to S and open bracket. There's a production S derives parenthesized E. So now that I've obtained open bracket E and close bracket, I need to reverse these values and substitute and replace it in the place of dollar. So here I would write dollar in the place of S, sorry. So here I would write this open bracket would turn to be, open bracket would be there, then E I'll write, and then close bracket I'll write. Now open bracket exponential close bracket and dollar. When you're comparing open bracket and open bracket, that is two same symbols, in that case you can pop that particular symbol or element. So these two are popped. So we'll have dollar open close bracket and E here, and on this side we have exponential symbol close bracket and dollar. So if you take the combination of E and exponential symbol, yes. So M of E comma exponential symbol, you would get E derives SE dash. So in the place of E you would write SE dash in the reverse order, so E dash S. So it would be dollar close bracket E dash followed by S, and you'll compare S and the exponential symbol. So you get M of S and exponential symbol. If you compare, you get S derives exponential symbol. So in place of S you will substitute this E dash. In place of S write the symbol and dollar. Here you can see two same symbols are there, pop exponential symbol. Now you are left out with close bracket and E dash, and here you have close bracket and dollar. So E dash on close bracket you get M of E dash on close bracket you get E dash derives epsilon. So in the place of E dash write epsilon. So you write dollar close bracket and epsilon here, and close bracket and dollar. Comparing epsilon and so one thing, if you get epsilon you need not write it here, so you can neglect it. So you have dollar and close bracket here, here also close bracket and dollar. Comparing close brackets, both are same, so you can pop that. So you will be left out with dollar, dollar here. So when you reach such stage where in the stack there's a dollar and in input also there's a dollar, it means that the parsing is done successfully. So here parsing is successful. So this is how we check if the given grammar is LL1 or not, and we also show the sequence of moves made by the parser on the given string. So I hope you have understood how to solve this question. If you have any doubts, do let me know in the comments and subscribe to my channel. Thank you.